Okay, so now we're going to talk about functional notation. And you're probably used to seeing things in high school like y equals 3x minus 4, an equation with x and y. And remember, back in high school, if we wanted to figure out what a point was on this particular line, we could, for example, put a 1 in for x. And we could figure this out. We could go y equals, that's going to be 3 minus 4, which is really negative 1. And that corresponded to an x value of 1 and a y value of negative 1. All right. So now notice this equation that I've written right here looks almost exactly the same as this one here, but instead of having a y there, I have f of x. And we read that f of x when we say it, f of x. It means the function with x as its variable. Okay, so the function of x. All right, so this actually means the same thing as this equation y equals 3x minus 4. So remember that and keep that in your mind for the rest of the semester, that f of x is really the same thing as y. It is equal to y. All right, so it's just a notational change. It's not a real change in meaning. All right, so if I wanted again to find a point and I wanted to use 1 for my x value, it would look like this within this notation. So if I plug a 1 in, notice I plug it in on the left side in the notation, as well as plugging it into the right side, and then I would work it out like I did moments ago to get negative 1. Now, that notation allows us to write things horizontally much easier, and it tells us that we also are dealing with a function when we see that functional notation. So it gives us a tiny bit more information than the y equals 3x minus 4, which is a function, but we don't necessarily know by looking at it that it's a function. By having that f of x there, it tells us this is definitely a function. Now, I can also write 1 minus 1 is the same thing as far as a point is concerned, just like up here. And we would find if we graphed y equals 3x minus 4 that this point would be on it, and this actually is the same exact graph for f of x equals 3x minus 4. So let's practice a little bit of functional notation. Okay, so whatever is in the parentheses in the functional notation, up here in the function that I have, and I have this function f of x equals 3x squared minus 4x plus 3, we want to find f of 2, f of a plus h, and f of negative a. Whatever's in these parentheses is what I'm going to replace my x with. And if you will think every time you do one of these problems, wherever there's an x, just put a parenthesis, just like this. Put a parenthesis. So notice that I've replaced all my x's with parentheses. Now I'm going to copy that because I'm going to show you just if you do that, how easy it's going to make these ones that don't have numbers. So I'm going to do that for every single one of them. I've just replaced all my x's with open parentheses. All right, so let's do this first one. I am going to put a 2 in where the x's were, so into the open parentheses. And now we can work this out. So remember your order of operations. You must do the exponents first. So we've got to do that 2 squared first. So this is 3 times 4 minus 4 times 2 plus 3. And now let's do our multiplication. 12 minus 8 plus 3. That's going to be 4 plus 3. That answer is going to be 7. And if the answer is a number, I can write this as a point on the graph. I put in a 2 for x. I got a 7 out for y. Okay. So let's do the same thing with the next one. We were replacing our x with an a. So we're just pumping an a into here and putting an a into there. Now, the only thing I can do to that now is just clean it up by taking the parentheses back out and making it 3a squared minus 4a plus 3. And that's it. It's done. Now, if we wanted to, we could list that as a point, but of course, it's not a point we could locate. The x value would be a, and the y value would be 3a squared minus 4a plus 3. All right, now let's do this next one. We're going to have to clean this next one up a little bit, and this next one is going to set us up for something we're going to do in my next video. So let's replace the x with a plus h, or we are going to think of just dropping a plus h into the sets of parentheses that I made. Now, to clean this up, though, we've got to do a little bit of algebra here, multiplying things out. I want you to remember that a plus h squared really means a plus h times a plus h. And I'm going to go ahead and distribute that negative 4 through those parentheses. So that's negative 4a, negative 4h, and then I still have a plus 3. But we still need to multiply all of this out right here. I'm going to multiply the a plus h's first, and then afterwards I'll distribute the 3. So I'll leave the 3 alone here. Let's multiply out the a plus h's. A times a is a squared. A times h is ah. H times a is also ah. And then h times h is h squared. And then I still have my minus 4a and my minus 4h and my plus 3. Now, I'll go ahead and distribute that 3 through those parentheses. I'll have 3a squared plus 3ah plus 3ah plus 3h squared minus 4a minus 4h plus 3. Now, that's almost done. The only thing that I can still do to it is add these two like terms right here, 3ah and 3ah. So my final answer is 3a squared plus 6ah, when I add those two like terms, 3h squared, and then minus 4a minus 4h plus 3. And as ugly as that is, we're done with it for the moment. Now, you'll see in the next video, we're going to do more with this f of a plus h idea, but we'll come back to that in the next video. Let's go to the last one of these. Notice that what's in the parentheses here is a minus a. So we want to replace all of our x's with a minus a, or we can think just drop them in to the parentheses we made, minus a. All right, now just a little bit of cleaning up to do on this one. When we square that negative, it's going to become a positive. So really we have 3a squared, because the negative is going to disappear on us when we square it. And then here, negative 4 times negative a is going to become a positive 4. So we have positive 4a, and then plus 3. And then that thing is done. So practice that functional notation, and if you'll think of what I did with each one, I replaced the x's with parentheses, and it makes it a whole lot easier to think about what to do at each step once you've put things in correctly.